Okay, next we are looking at question 5 and question 6. Okay, question 5, we are supposed to sort tuples using insertion sort. So same thing as the gender age one. So write program code for a function sort age that uses insertion sort in the list and return the list with the older person in the front of the list. You may assume that no, so for example this M23, F19, M30 should return M30, M23, F19. So you realize that for all the sort algo, right, you have this question. Basically forces you to go to tuple. Okay, so I'm just going to copy paste this code and then put it into cosmology. I'll put it into Jupyter. I'm just going to remove this one here. Let's remove it. Okay, so let's do it. Okay. Sorry, I want to put it above here. Okay, so over here. Alright, this is what I'm supposed to do. Alright, so what I can do is that we can actually make use of the code from question 3 over here. So that will help us to simplify our task. Alright. So let's just maybe let's copy some stuff. Okay, if you look at this code, right, this is just checking this code. The original insertion code does two things differently from what we want from question 5. First, it is accessing the elements of the list already. So these elements here are integers or floats. Right, it's not in the tuple. So that means now we have to access when we look at our list here, right, we have to access. These are the elements. Each element is a tuple, so you need to access index 1 over here. So that's one thing. Second thing, this code is designed to sort the smallest number on the left hand side. Okay, so I want it the other way around, and I hope you can see that the key is just this portion here. This portion needs to be different. Alright, so let's just okay, I think I won't copy paste the code because it might be a bit hard for to follow. Okay, so first thing first, let's check for the len list. Len list must be less than, if len list is less than or equals to 1, I return list, because a single item list or empty list is already sorted. There's nothing else to do. Right, so now we can go on. So same thing, let's look at reference above. We do our range from range 1, for loop from range 1 to len list, right? So this will be for I, let me just scroll a bit. Okay, for I in range 1 to len list. Alright, okay, so now I do my while loop. So while here, right, so this while loop, this is the part that's changing really. So this list I minus 1 and this one has to be different. So this one I have to change this only if I do it this way, right, you only reach the tuple. Okay, if I reach the tuple, right, I'm comparing the whole tuple. If I compare the whole tuple, say I compare this tuple and this tuple here, right, the first comparison will be via it will look at the first item of the tuple. So in this case, it will look at M, or just M is larger than F so it comes first. So that's fine But later on, you see there are some issues. Say for example, let me find one. Okay, F18 where? Okay, so I'm trying to find a good example. Okay, so let's say, oh yeah, I can't think of an example. Wait, F18 M23. F18 M23. This one should come first. So I need a case where where am I doing? M70, M30, M. Okay, M is larger. Okay, so do I have a female who is older? Okay, F18. No, yeah, I'm trying to find examples inside this, but I realize there's not any. Oh yeah, F19 and M17. Alright, so if you sort by M, right, sort by tuple, right, M will come first. Okay, which is not what I want, because I want to sort by age. Okay, so this loop here has to be careful. I'm just going to copy paste this line. Okay, I'm just going to copy paste this line and make the modifications to it. Okay, so some copy pasting involved. Okay, so let's copy paste this one over here and bring it here. Alright, okay, so now I need to index 1. Okay, index 1 to reach the age. Okay, reach the age. Then I need to, because I want to sort in descending order, right, so I have to go the other way around. Okay, so let's just put some notes here. So I need to index 1 to reach to access age. Okay, change to this to sort in descending. Okay, okay, so that's it. Okay, now when I do the swap, right, be careful not to swap this. Okay, because this one you're accessing the tuple. I want to swap the entire tuple. So if I were to swap, right, let's say for example, if I want to swap this to 19 and 30, right, I don't just want to swap the number, I want to swap the entire tuple. So this entire tuple needs to come in front of this F19. Okay, so I will do that normal swap. So this swap line is the same, no change. I'll take this one. Okay, in fact, the next two lines, the rest are the same lah. So I'll just copy paste it. Alright. Okay, over here, I'm just going to press enter so that we can put in. Alright, return list. Okay, so let's test this one. So let's do maybe for sequence 1. Okay, so sort h sequence 1, see what we get. Okay, so we get it correctly, yeah. Okay, so yeah, we can try for one more. Sort h sequence 2. Okay, so 2 is this way. So 30, then 23, 19, 18. Okay, so that's it for question 5. Okay, we look at question 6 right now. Question 6 is quite interesting. Question 6, you're supposed to write additional lines of code to count and return the number of compressors made in completing the sort process. Okay, this will indicate efficiency. Okay, so you want you to return it in the form of a tuple. So you return the sorted list, okay, then the number of compressors at the back as a second item in your tuple. Okay, then we look at the test cases. This is important to the test cases. So for example, if there's no compressor made, let's say for example here, right, where there's only a single list, right, you just return that list and then the number of compressors is 0 lah. Okay, then after this the compressors. Okay, so let's do the first one first. Let's do the first part. First part is easy to do. We just need to, for when we go back to our code here, so basically I can duplicate this code here lah. I can duplicate this guy. Okay, I'm going to put it at the bottom, put one more line here. Okay, so let's just take this code. Okay, sorry, let's just C then V. Okay, so over here. Okay, so I want to modify this. So if my list is contain 1 item or 0 items, right, there's no need to sort. There's no need to do any sorting. So the number of comparisons is 0. So I just return list, 0. So let's test this with a single item list. So let's do sort hi, just do a single item list. Just duplicate one of this list and then call it maybe sequence 0. Okay, sequence 0 will just contain 1 item like this. Sequence 0. Okay, let's try sequence 0. Okay, so there's nothing to sort. It should just return like that. This is what we want. Alright, so this is for the first case. Alright, the second one is harder. The second portion here, right, we need to think of how many compressors we make. Okay, so the problem here is that remember when you compare, right, compare doesn't mean you will swap, right? So that means the moment you make one compressor like this, okay, so this is the outcome of a comparison. Okay, as long as you're comparing two numbers, two edges here, right, this is counted as comparison. Okay, so every time you successfully enter a loop, right, it will count as one comparison. Because if you can enter the loop from here, from this while, if you enter the while from here, that means you have actually made one comparison. Okay, and also this one must be true at the same time. Okay, so let's check our answer here. So that means now I need to indicate a counter. So let's call this count equals to 0. Okay, so every time I successfully enter the loop, I will update count plus equals 1. Okay, then return list. At the end, I return list count. Okay, so let's check answer. Let's look at maybe one of the test cases. Let's see what they have. So if I sort sequence 3, I should get 7. Sequence 1, I should get 10. Okay, and sequence 1, I should get 3 lah. Let's try sequence 1 first. Sequence 1, see what we get. Okay, we get 2, which is wrong. And then if we do for sequence 2, we get 6. Okay, we get 5. Sequence 3 is supposed to get 7, and sequence 4 is supposed to get 10. So sequence 3, we get this. So we are all short about 1 or 2 lah. Okay, if we analyze this a little bit more, let's look at this portion. I'm going to remove this line so that it's a bit cleaner. Okay, so over here, if you think about it, right, your counter, right, will only advance if these two conditions are met. Okay, so there are two possible reasons why you didn't enter the while loop. First reason, you made a comparison, but your I is already equals to 0. So if this is true, you have made a comparison. Okay, but if your I is equals to 0, right, you will not go in, so you will not encounter this. Okay. Second one is that while this is true, okay, you have I want to say, if you have made this comparison, let me check my code for the bottom forward share. Yeah, I0 I minus equals 1. Okay, so let me I previously done it, so I just want to recap what I've done. Okay, I larger than 0 count plus equals to 1. Okay, what was doing here? How did I get the answer for here just now? I larger than 0 count plus equals to 1. Okay, so the reason is okay. I get it. Okay, so remember, if I equals to 0, right, there's no comparison made. I equals 0, there's no comparison made. So if I is larger than 0, a comparison was actually made. But then because this comparison was not true. Okay, so it wasn't added. So I would add one more outside. So that means I'm checking for I larger than 0. If I larger than 0, right? Okay, this means the last how do I explain to you? If this is so let me write out down first. Count plus equals 1. Okay, so what is happening here is that when I complete this loop, when I break out this loop, when I end this while loop, right, I will come to here. Okay, so if I is larger than 0, count plus equals 1. Okay, so that means I'm looking at the last time this while loop was checked. Okay, the last time this while loop was checked, right, if I is still larger than 0, but you still broke out of your loop, right, that means this is not true. This is false. But that means at the same time, a comparison has been made already. Okay, so however, if I is equals to 0, right, then no comparisons have been made lah. Okay, so I think this is the best I can explain. I think you have to try for yourself to see what we get lah. So let's look at the answers now. Control Enter. So you get 7. I think that is correct. And then let's do for sequence 4. We should get 10. We do get 10. I'm just going to copy paste this code into Cosmology and hope that it runs normally. Let's just put it into here. Okay, and then let's run this guy and see what we get. Okay, I hope this is okay. Yeah, so it's okay. Okay, so this is all for insertion sort, right? Thank you.